What? Nothing. So unlike screen visible. Hello, online screen visible auntie.
Yes.
Yes, sir.
So today we are going to discuss about one more algorithm, that is KNN. Today algorithm is KNN. The full form of KNN is K nearest neighbor. K nearest neighbor. So this is a full form of KNN. It works for both classification. It works for both classification as well as regression. That's why we simply say it is also a supervised learning algorithm. And that comes under the supervised learning algorithm. So for example, let me take. Okay, let me take first classification. Let me discuss about the classification report, like classification data. Okay, if you have a classification data, so that it is the x-axis and y-axis. This is the x-axis and y-axis. This is the x-axis and y-axis. So in x-axis, I have a two classification things. This is the one type of data. This is the one type of data, and this is the another type of data. Classification, right? This is the one type of data, like red data and black data. I have a thing. So what if happen if one new data is came? If a new data is came to the old data, so it need to be clarified whether this data belongs to this type or this category. We need to identify the new data points belongs to the black category or red category. So this is a process we need to apply the KNN algorithm. First, we need to identify the K value. First, we need to identify the K value. So here K is considered, like we need to consider what are the values is near to the new data point. What are the values near to the new data point? Calculate the distance. Calculate the distance. We need to calculate the distance. Okay. For distance calculation, we have a two methods. First one is Euclidean distance. Euclidean distance. Second one is Manhattan distance. Manhattan distance. Euclidean distance, and second one is Manhattan distance. So first one, Euclidean distance formula is, to find the Euclidean distance, we need to identify the distance between the 2 points, x1, x1 y1 and x2 y2. We need to identify the 2 points. So distance formula is root of x2 minus x1 whole square plus, this is the old age formula, x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula to identify the distance between the 2 points. To identify the distance between the 2 points. So based on this distance, we decide whether this value, new data points, is belongs to black data or red data. Black data or red data. We just define. So for example, consider k equals to 5. Consider k equals to 5. So if they collect the 5 data points, consider k equals to 5. Select the 5 data points. Okay. Select the 5 data points. So this is the near one. This is the near one. So for example, these are the 5 near data points. These are the 5 near data points. Collect 5 near data points and calculate the distance. Calculate the distance. Which distance is less? That data belongs to the that category. Okay, which data is written. So if this distance is less, this new point is belongs to this category. If this distance is less, this new point belongs to this category. Okay, like that we calculate the data point. If a new data point occurs, we simply calculate like this. Age దగ్గర ఉంటే దాంట్లో కేసెస్. Okay, let me show you the Manhattan distance formula also. So Manhattan distance is simply we need to calculate. Simply we need to calculate Manhattan. Yeah. Simply we need to calculate. So mod of x2 minus x1 plus mod of y2 minus y1. Mod of x2 minus x1 plus y2 minus y1. How we are calculating it? Let me define the entire formula first for the Euclidean distance. Derive the entire formula. You can clearly understand how we calculating that is. So for we have a x-axis and y-axis. Okay, x-axis and y-axis. We have one data points here. This is the data point x1, x2, y1, y2. So this is the data points we have. So by using this is a right angle triangle, it will like this, right? Between these 2 points, this works and enlarging this thing. It is A, B, C. A, B, C. Apply hypothesis testing. Sorry, apply that's Pythagoras theorem. Sorry. Apply Pythagoras theorem here. What is the Pythagoras theorem? Hyperplane like this AB square plus BC square. Pythagoras theorem. Okay, where A equals to root of A square plus B square. Root of A square plus B square. AC equals to root of A square means x1, x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula I have found. This is the Manhattan formula. Manhattan formula. Simply, I am living in Hyderabad. I need to travel for Delhi. Just going in a flight from the Hyderabad. Just only one straight line we have. So in Manhattan distance, consider. Did you play the GTY City game? GTY City. So GTY City, city like in foreign they have city like this. So they place the entire like this only. This is the places. అంటే ఎంటైర్ ఇలానే ఉంటాయి వాళ్ళ సిటీ అంతా ఇలా ఉంటుంది బిల్డింగ్స్. సో రోడ్డుకి పర్ఫెక్ట్ రోడ్ ఉంటుంది అక్కడ. ఓకే, సో ఐఎమ్ లొకేటింగ్ హియర్, మై హోమ్ ఈస్ లొకేటింగ్ హియర్, మై ఇన్స్టిట్యూట్ ఈస్ లొకేటింగ్ హియర్. ఐ నీడ్ టు ట్రావెల్ ఇన్ సమ్. సో దెర్ ఈస్ సమ్ వేస్. We are going like this or straight line, or I can go for like this, or this is the straight line. So there is only straight line. We don't have jumping. We don't have any jumps. So there is a straight line. So that's why we calculate this Manhattan distance. Mod of x2 minus x1 plus mod of y2 minus y1. So because when we go like this, we just only get the positive direction. We didn't get any negative direction. It works like this. Here, Manhattan distance and Euclidean distance. Right now we do for the classification. Now we go for the regression. How this work for the regression? How it's work for the regression models? Same, I'm taking x-axis and y-axis in the x-axis. Okay. Same, I'm taking x-axis and y-axis. So this is the data points I have in a regression. This is the data points I have in a regression. This is the data points I have in a regression. So when the new data points is founded, I need to calculate the distance between the data points. Same, I need to calculate the distance between the data points. Which data points it belongs to? I need to convert it. Same data points. If we have a regression also, we need to calculate the distance. We need to calculate the distance and mention the average. So if, for example, this is my data point. This is the nearest values I found it. This is the nearest values I found it where k equals to 5 and apply the average of these 5 values. Apply the average of these 5 values. If you apply the average of these 5 values, you will find the exact value of a new data point. Exact value of a new data point. దీంట్లో రిగ్రెషన్ లో మనం యావరేజ్ చేస్తాం, క్లాసిఫికేషన్ లో సపరేట్ చేస్తాం. సో ఇక్కడ యావరేజ్ చేయాలి, యావరేజ్ ఆఫ్ ది 5 values. Then we can find the exact value of a new data point. Okay, exact value of a new data point. Here. Here. So in KNN, we have some limitations. In KNN, we have some limitations that are KNN does not works for the outliers. It does not work for the outliers because if our data contain like this, like this is the black data and some node data is contained like this. If some data is contained like this is the outlier point. If a new point lies here, it is also considered as the outlier only. So that is the effects of that. KNN does not work for the outliers and it is also does not work for the imbalanced data. Imbalanced data. Here we find this new word, imbalance. What is mean by imbalance? What is the difference between balanced data and imbalanced data? What is the difference between balanced data and imbalanced data? Simply, if you consider as a classification, if S contain 600, nose contain 400, this is a balanced data. It's a small ratio difference. Oh, 1000. Overall 100. So overall 1000. If S contains 600, if Y contains 400, it's a balanced data. So if F contains 900, Y now contains 100, it is a imbalanced data. It is a imbalanced data. So small variation is fine. Huge amount of variation is not good. If we have a huge amount of variation, we consider it is a imbalance. Small amount of variation we have, it considers a balanced data. 500 అవ్వచ్చు, 400 600 అవ్వచ్చు, 550 450 అవ్వచ్చు. It's complete. So we don't show this much of variation. If we have found this much of 900 100, it's a imbalanced data. Clear? Understand? This is all about your K nearest neighbor algorithm. K nearest neighbor algorithm. It is collecting the data based on the distance classification. If a new data point came to the new data set, it calculates the distance first and categorizes that data point which category it belongs to. Okay, this is all about the typical concept of K nearest neighbor. K nearest neighbor. Done? Understand? Online? Understand? Offline and online? Understand? This is our entire K nearest neighbor. Okay, let me move for the practical implementation. So K nearest neighbor is a wide range of classification and regression. Like it goes for the classification and regression. So it is created the instant based algorithm. So mostly work for the classification purpose only. So it is a lazy algorithm. It is a lazy algorithm. In machine learning, entire machine learning algorithm, K nearest neighbor is the laziest algorithm. Okay, it is also interview question. Which algorithm is the laziest algorithm? A nearest neighbor is a lazy algorithm. How does K nearest neighbor works means? First step, select the number of K values. We need to select like 5, 3, how many? Like mostly selecting the odd numbers only. Don't select even. Only select the odd numbers. First step is select the number of K values. Second step is calculate the distance between the K number of values. How many values we taken and the new data point. Calculate the distance use Euclidean distance or man-handling distance, and take the k nearest neighbor as per the calculated distance. You need to take the k nearest value after the calculation. If you get the distances right, after that, among the clear, count the data points which is each category. So if A and B is the two category, new data points is content like A category is 3 and new B category is 2. So we need to assign the which category this data point and assign the data point for that category. And our model is ready. This is the process. Okay. We have it. So like this, we have a x-axis and y-axis, class 1, class 2, same there. So first one, I need to select the target point. This is my new data point, and I need to find the distances, and I need to tell the which data belongs to this. So this is a graphical representation. So we can calculate the distance by using the two types. One is Euclidean distance and one is Manhattan distance. So we are calculating Euclidean distance Pythagoras theorem. So this is the formula x2 minus x1 whole square plus y2 minus y2 whole square. So next we are going to calculate the Manhattan distance. Simply it is a mod of x1 minus x2 or x2 minus x1 is the same or y1 minus y2. This is the Manhattan distance. So for implementation purpose, I am importing packages, pandas, numpy, matlab, and cbon. So from sklearn model selection dot import line test spec, it's common thing. And standard scalar, if you want to apply the normalization, we can also implement the standard scalar. Okay, also implement the standard scalar. So if you want to import k nearest neighbor, you need to import from sklearn dot neighbors import k neighbors classifier. K neighbors classifier. If you import like this, we are working on the classification. K nearest classification. We are working on K nearest classification. Okay, na? How to import KNN algorithm? From sklearn dot neighbors import K neighbors classifier. If you are using classifier, you can use the K nearest neighbor. If you are working on the regression, you can use the regression. K neighbor regression. Okay. K neighbor regression. K nearest neighbors. So after that, I am taking my dataset derivatives. So take the derivatives. Head, load the dataset feed underscore read underscore CSV. So I load the dataset and the head and the information of a dataset and the shape of a dataset. So and I am finding the is there any null values present in a dataset. So df dot is nan dot sum. If there is no null values. So here the main thing is we have a installation is the main thing in the derivatives. So installation consider like total number of installations is there is a record is 61,281. So there we contain so here in installation 0 installation is 0, 1 installation per person is 0, 3 installation person is 94, 4 installation person is 128. Mostly these are the values of installation, how many people are installed. Okay, based on this and x-axis I connected with df ilog of this is the location of total and y-axis ilog of 81. This is the location. Train test split, applying the train test split. And if you want to apply the standard scalar, you can apply the standard scalar also for the x train and y train. X train and x test. So CF equals to k k neighbors classifier, n estimator equals to 11, PT equals to 2, number of points, PT equals to 2, matrix equals to Euclidean. Here the P is a power of Euclidean distance. There is a x square y we use now. C equals to power of Euclidean distance. Okay. So k nearest neighbors equals to neighbor 11 neighbors. I need to collect the 11 points initially. So CFL equals to fit x and y test and predict the values. These are the predictions. These are the predictions. These are the predictions. Then this is my entire things. First, I need to find the data. I didn't done any visualization. You need to done the visualization here and analyze the data more. Basically, we don't have any null values. So just analyze the data and perform these things. So this is all about your K nearest neighbor algorithm. K nearest neighbor algorithm. Understand? Got it? Not got it? Got it? Got it. Got it. Okay? Got it? Amrita. Online. Vijay and Pavani. Got it? This is your entire data. Algorithm చెప్పాలా? అంటారా? Practical గా చెప్పాలి. So that's it. బయట కూర్చొని ప్రాక్టీస్ చేయండి మీరు కూడా. ఓకే, ఎనీ డౌట్స్ గైస్ ఆన్లైన్? No doubts, right? So if you don't have any doubts, you can leave the class. We'll bite a practice training. That's it, guys. Thank you. Thanks for joining the class. Have a great day. Bye bye. See you. Tata.